So in this video we're going to be covering the construction and the working of DC motor, DC direct current motor, and we're starting right now. Hey, this is Advait. Welcome to another video. If this is your first time here and you want to learn how you can build your memory, build your brain by uncovering fascinating facts and clever academic concepts, start now by subscribing and clicking the bell so you don't miss any of our videos. So we are going to be doing this on the big whiteboard. So let's jump over there. Now we will understand the construction of a DC motor, DC direct current motor. We'll do this construction in less than 2 minutes, so take your scalar pencils and take a notebook so that you can draw along with me. So let's draw the first step. Draw two rectangles with scale and pencil. Don't draw freehand. Scale and pencil must use. So we have drew two rectangles. Now let's draw one more rectangle, but don't complete the fourth set. Let it be handicapped. Sorry. So now extend this, and at the end of this, draw sort of a ring. Again, draw with proper scale and pencil. Hope you did that. And now draw one more rectangle, joining the two brushes like this. Okay. Now connect this. Connect these two rectangles with a battery. So now the final step is draw a cylinder in between the rings. If you don't want to draw also, it's okay. I recommend you to draw. So now we are completed with DC motor. Yeah, that's all. It's over. Now that we drew the DC motor, let's label them. These are the north and south poles of a magnet. And this is the armature coil. These are split rings. This is the battery itself. Let there be positive, negative. Mark these positive and negative, it's important. And split rings, this is carbon brush. This is the label diagram of DC motor. So now let's understand the working of the same motor which we drew right now in a moment. Now we are done with construction, let's understand the working. So let's get on and draw the diagram again. Let's draw the armature coil. So now that we have drew the motor, let's mark the direction of conventional current. So it will go from the positive terminal to the negative terminal. Yeah, true. So let's draw that. Okay, so the current takes a complete cycle and ends over here. So now why are we taking conventional current instead of the electron flow? I'll tell you why. As you may know right now, we use Fleming's left-hand rule for this, and Fleming's left-hand rule was based on the concept of conventional current. What I mean by that is that when Fleming discovered that there was a law of Fleming's left-hand law, they followed conventional current at that time. So one finger denoted current if you know the Fleming's left-hand rule, and that current was conventional current at that time. That is why we are following conventional current rule. Now let us look. So now we know that the magnetic field lines originate from the North Pole and moves towards the South Pole. So therefore, magnetic field lines is in this direction. Dock up pen. So magnetic field is from this direction to that direction. Now I will give you a short recap on what is the Fleming's left-hand rule. So Fleming's left-hand rule says that if we draw the thumb, the forefinger and the middle finger in such a way that each of them is mutually perpendicular to one another. See, this is perpendicular to this is perpendicular to this, and this is also perpendicular to this. So now, if the index finger points out the direction of magnetic field, and the middle finger points out the direction of current, then the thumb will point out the direction of force on the current carrying conductor. I'll tell you what that means. Now we know the magnetic field is from this direction to this direction, from north pole to south pole. One more important point, the DC motor we have drawn is the upper view. If you have studied visualizing solid shapes or something like that, there will be upper view, side view, bottom view, blah 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 view. So this is the upper view. That means we are looking at the motor from up. That means the motor is over here and we are looking like this. We are looking down on that. So now this is the upper view. Since the magnetic field moves from north to south, that means the forefinger should point this way. And the current is moving into the plane because now we are seeing it downward. That is why if the DC motor is like this, the current is flowing this way in this coil A, B, C, D. Let's mark. So in the side AB, current moves from A to B. That means it moves inwards. Now this is the upper view. That is why it is looking like it is going upwards, but it's not going upwards. This is the upper view. I told you that. So it is moving this way. A is over here, B is over here, and it's moving from A to B in this direction. So if the middle finger should be drawn out in this direction, and the magnetic field is this way. So if we extend out the thumb, we find that the thumb points downwards. That means the force on the side AB will be downward. What that means is that if AB current, the current on AB is moving from this direction A to B, and the magnetic field is from north to south, obviously it's from north to south, so the AB will experience a downward force. So AB will move downwards. What will happen to CD? In CD you can see, obviously the magnetic field is same. So if we point out the index finger like this, and the current is moving from C to D, from this direction to this direction, it is moving out of the plane, should I say. So because this is the upper view, remember that. So if you look at C and D in this way, it moves from C to D, C to D, because D is here, C to D. So middle finger would point in this direction. So if you extend out the thumb, we see that it is pointing upwards. That means CD experiences the force upwards. So if we see AB has a force downward, CD has it upward. What that effectively means, since AB and CD are connected, obviously it is a rectangular coil. AB moves down, CD moves up. What you can see is a rotation. Simple. AB moves down, CD moves up. AB moves down, CD moves up. So you get that CD upward force, AB gets the downward force, so it starts to rotate. So that is the basic principle of DC motor. So this is the first part until half revolution. I'll tell you what that means now. Now if we rotate AB and CD, in turn AB will come in the place of CD and CD will come in place of AD. So we'll look at that aspect after one half revolution in a moment. Now let's draw the DC motor after one half revolution. I'll tell you before that half there is one small point when the rings are not in contact with the brushes. I'll tell you what that is. Okay, so let's draw the magnets. North pole, south pole, armature coil. I'm not drawing the that cylinder stuff, the shaft one, because it takes time, kills time. Let's draw the brushes, battery. Now we know that AB has moved down, CD has moved up, so there's a rotation. And then after half rotation, AB takes the place of CD and CD takes the place of AB. So it will be reversed. So the coil will now be DCBA. The current is still flowing the same direction. And an important point to note is that if in the first case, if the left side ring was R1 and the right side ring was R2, the ring actually rotates, the split ring or actually rotates with the armature coil. So now the ABCD has interchanged the position, so therefore the split rings will also interchange their positions. So this will be ring 2, this will be ring 1. Okay, I'll tell you with both the diagrams in a moment. So now we can see the current is still moving in the same direction. It is moving the same, whatever direction it is. I think it's clockwise. Yeah, it's clockwise. So now the current moves from D to C. D to C, okay. First it was C to D, now it is D to C, because you can see the battery didn't rotate. Only the coil and the rings rotated. The brushes still remain the same, B1, B2, and the battery still remains the battery with positive terminal here, negative terminal here. So now the batteries from the positive terminal, conventional current flows in this direction. So conventional current is flowing from D to C in this side, and north to south, north and south poles remain the same right now. So we know that the magnetic field is in this direction. Okay, still the upper view D to C, that means it's moving from D to C. It's moving into the plane. So therefore middle finger will extend this way. And so if we extend out the thumb, we can see it moves downward. So in case 2 or after half revolution, DC experiences a downward force. Let's talk about AB. Now the current moves from B to A. See, it takes one revolution and it moves from B to A. So therefore, if you look at the current's direction, it is this way. It is moving from B to A. It's moving out of the plane. So middle finger will be pointed out this way. The north to south will be pointed this way, the magnetic field. So if we extend out the thumb, we can see that the force is upwards. So now it has actually interchanged. If you can see here, AB was experiencing downwards. After half rotation, AB is experiencing upward force. In this, similarly, CD has also interchanged the forces. This interchange of forces is due to the split ring type commutator. That is the function of a commutator. To reverse the direction of current, first it is moving in the direction ABCD. Correct? Now it is moving from DCBA. So this is the function of a commutator. I hope I spelled it correctly. I don't know. Maybe I know. Okay. So this change in the current's direction will also change the force's direction. So now if we can see, DC is moving downwards, AB is moving upwards. So it happens like if DC is this right hand and my AB is left hand, for you it is left hand, right? I don't know, lateral inversion. So so DC is moving downwards, AB is moving upwards. So DC AB, it will complete another half rotation and it will come back to the original position. DC will be in the place of DC and AB will be in the place of AB. So therefore, one rotation is complete. So this was one half, this was the second half. Now actually we'll compare both of these with both the diagrams in a moment. So now this is the both diagrams. This is the first half rotation, this is the second half rotation. Let's look at the first half again. Short recap. So current moves from positive to negative. So current moves from A to B, current is in this direction, and applying Fleming's left hand rule, current is middle finger, so it is moving from A to B. This is the upper view as I told you. So the current is moving into the plane, and magnetic field is always north to south. So magnetic field is pointed by the forefinger, and if you extend the thumb, we can see that the thumb points downwards. That means on the side AB, there's a force downwards. So there's a force downwards in AB. In case of CD, CD is now as the current moving in this direction. It is moving from C to D. This is the upper view I told you. So middle finger will point this way. Magnetic field is still from north to south. And if you extend the thumb out, so CD is now experiencing a force upwards. The downward and upward forces on opposite sides will create a rotatory stuff. Okay, so the CD will move up, AB will move down, so it will facilitate in rotation. So there will be a point, the rings will also rotate, I told you. So R2 will move this way, and there will be a point where the ring will be like this, and the brushes are like this. So as you can see, the brush is not in contact with the ring now. So how will the rotation happen? Because the current will not be there in the coil. Now, if you have studied 9th standard first law of motion, that is inertia of motion. When the body is in motion, unless and until compelled by external forces, it will keep on rotating or it will be in motion. So same case goes. So it was rotating, and since the current stopped, it shouldn't stop the motion because there is not that much air friction upward or downward to stop the motion. So that is why, due to inertia of motion, the coil keeps on rotating. And this will be R1 and R2. So this R1 and R2 has rotated along with the armature coil to get into this position. And after half rotation, R2 will come over here, R1 will come over here. That is the second case over here. So the battery hasn't rotated anything. So let's mark the current. It's the same. So now ABCD, now it's DCB. And now we can see that the current is moving from A to B to C to D. Here from D to C to B to A. So the current's direction has changed. It hasn't changed. It is due to the inverse or something. The current is still moving from positive to negative, but the thing is that the coil interchanged its sides. So that is why we say that the current's direction has changed, and that is the function of split ring, and that is why it is known as commutator. So now if you can see, current is moving from D to C, and north to south is in the same direction. Magnetic field, it is moving from D to C. The middle finger will point this way, and as we can see, thumb is pointing downwards. And if you look at AB, it is moving from B to A. So the middle finger will be pointed this way. Magnetic field is still the same from north to south. And if you point out, extend the thumb out, it will be upwards. The force experienced is upwards. So therefore, here it is downward, here it is upward. So therefore, it will complete the rotation. And again, after this, it will come back to this position again. And the process continues, and that is how the DC motor rotates. So now we will label what is the external circuit and the internal circuit right now. So you can see till this part, this is all external circuit. That is, external circuit contains battery, wire, any load if there is present, there's no load over here, and the brushes. And fact of the matter, brush is made of carbon. Why? Or should I say, brush is like a brush. It will not be it will be like this, and will be brushes like this. Why? Number one reason, it increases the surface area so that current passes through the ring and the motion is facilitated due to increased surface area. This is point number one. Point number two is that here it is carbon. Carbon is nothing but graphite. So graphite has high melting point, and that is why it will not melt easily even though current will pass through for long time. So that is why graphite is used, because it has high melting point. So the graphite will not melt due to the heating effects produced by the electric current, as we have studied Joule's law of heating. So these are the two reasons why carbon brushes are used. So external circuit now contains battery, wire and brush. Internal circuit is the rest. That is armature, coil, magnet. Magnet is not circuit, but anyway we'll consider it. And obviously the split rings. So this is the entire portion of DC motor, how it works. If you haven't understood the working yet, I would recommend you to watch the video again. It's really difficult to get it in the first time. If you rewind the video again, I guarantee you that you will understand this concept. So I made a Telegram group for all my subscribers where you can chat with me and our academic teacher there. The link to which is in the description. You can join there. It is absolutely free. And if you want to build your memory, brain, and clear academic concepts, start now by subscribing and clicking the bell so you don't miss anything. And watch the playlist I've linked on the screen right now. It is the light ray diagrams playlist, and soon there will be AC generator video which I will link after I have prepared in the screen right now. Thank you so much for watching. I'll see you next time.